Hello, my friends. Welcome to my another lecture, which is we'll talk about addressing the internet. This is our topic, which is subtopic for the internet. Anyway, we will look another topic, which is subtopics again. It is IP addresses. We will talk about IP addresses, and if we saw there's some question or problem, we'll solve together. Also, I was changed my style. Okay, I'm looking a little bit different. I know, like people, which is a singer. I mean, he have good songs. You can listen later. Anyway, I will go my topic again. We'll talk about IP addresses. Let's start with me. Okay. The Internet Protocol IP is one of the core protocols in the layers of the Internet. As you might guess from its name, it's used in all Internet communication to handle both addressing and routing, which is important. Everyone have unique IP addresses, and also we can say sometimes Google can generate for you new IP addresses to make internet faster. Okay, because sometimes your unique address can be little slow. For that, Google have some algorithm. They can generate very fast new IP addresses to reach to internet, to reach to Google. Anyway, let's go to the. I will go a little slow. Right here. Yes, here. The protocol describes the use of IP addresses to uniquely identify internet connected devices. It's all good. Just like homes need mailing addresses to receive mail, internet connected devices need an IP address to receive messages. It's like what, Just think you have phone, you have GSM phone, right? Numbers, and someone sending you messages, and you're receiving it, and then you sending to back to him or her. It's communicating hazard, right? It's all IP addresses is the same for the computers, like phone numbers. Okay, we will talk all each details about or what we are talking about. Okay, let's go down. Let's come little down to the here, right? When a computer sends a message to another computer, it must specify the recipient's IP addresses and also include its own IP address so that the second computer can reply it. Let's look here. I will come a little bit down. Let's slide it. We have here 216.3.128. Point anyway, so it's 12. Let's look. This 216 and 3. This is internet provider company, and if you look the right places, which is we talking about it like 16 bits. The 128 it is 18 bits. This is between 0 and 256. But we will speak about it in the later, so in the future. Okay, just don't worry with that. So the first one is sending from this IP to message to another place. Okay, this message is that it's going there and it's tagging this message. This is 5. Our message is the 5 here, right? It's going again. We have here 0, which is you cutting electric, and it's going on again, and it's stopping, and it's going on again. Anyway, previously we were talk about it, right? Anyway, let's go other topic. So which is it's sending these messages and this tagging this message to and sending back to there. But anyway, let's come down. I will be clear, so promise you. So our 5, it was gone there. Okay, now we will look now for the IPv4 addresses. This is generally we are using that, but alternatively we create their IPv6 uh, for the more computers, so for the more networks. Okay, let's come down. Look here, what we're talking about. There are actually two versions of the Internet Protocol in use today. IPv4, the first version ever used on the Internet, and IPv6, a backwards compatible successor. So, in the IPv4 protocol, IP addresses look like this. I told you, the first 16 bits, but you can think like this is between 0 and 256, 255, okay? Can be their possibility. I mean, and then this place, so this place is 8 bits, this place is 8 bits, this place is 8 bits, like that. It's going all the way like that. Anyway, don't worry about that. This is provider, and this place is your unique. Anyway, your unique IP address. So try visiting that IP in your browser. Where does it go? Do you want to try it? Let's try with me. What will happen? It will go Google, I think, with your IP address. Let's check it. Let's try. What will happen? Look. Yeah, this is IP address of Google. Let's go back. Okay. Let's come down. To I need to be a little slow. Yeah, maybe a little up. Here to here. Yeah. Each IP address is split into four numbers, and each of those numbers can range from 0 to 255. We're talking about it 8 bits, right? 8 power of 2, it's 256, but we're talking like 255, okay? Because 0 is also a number there, like that. So in four numbers we talk like that in four steps, so in four range, so we can see here 255, 255, 255 is all the way going like that. This number possibility can be between 255, okay? We write those numbers in decimal, but the computer stores them in the binary, like so, like that, okay? So in binary computer language it is that. Let's come down. Yeah, where to go? Where does it go? Um, yeah, each number can represent 8 power of 2 values thanks to the 8 bits. That's also why we often call them octets. So this is octets is always using for the 8 bits. So it's in the binary numbers. Okay, octets, we're using that. So also for 16, we're calling it like hexadecimal numbers. So we will see all that. Okay. Overall, that's 32 power of 2 possible values. It can be like that. This number for 1,294,000. No, no, 4 billion. 294,900. 967,296 possible IPv4 addresses. Okay, because why? I told you in each step we have 8 bits, 8, 16, and 16 plus 16, it will be 32. It's 2 power of 2. So 32 power of 2. It will give us this possibility for IPv4. Well, in the world, many more people living, so like 8 billion, we need alternative like IPv6. Let's come down in that point. Yeah, where we need to go? Okay, that's a lot. But remember, in the beginning, we said there are more than 4 billion devices. I told you connected to the internet. Well, we are we are reaching the limit of possible IP addresses. Time for Plan B. Now we will look for IPv6 addresses. Okay, let's come. Back when the internet protocols were first invented, the creators didn't anticipate how popular it would become and that there would eventually be more than two devices wanting to connect to the internet. Okay, when it became obvious in the 1990s that also we can say 1990s that the IPv4 addresses were running out, the IPv6 protocol was proposed with a much longer addressing shape. Let's come down. Okay, um, I need to be a little slow. Okay, here's an IPv6 address. Yeah. So you can see we have one, two, three, four, five, six, 7, 8. 8 point, and each point we calling it like F F F F. Okay, like that. We'll speak all of them. Okay, let's come down. Notice the letters in those numbers like D and B, 0D, B8, like those are hexadecimal numbers, opens in a new window, which means that the IPv6 address is much longer than it looks. Let's do some math to see exactly how much longer. There are 8 hexadecimal numbers, and each number is 4 digits long. The highest value for each number is FFF, since F is the highest digit in the decimal, hexadecimal. Thus, the highest, yeah, would look like FFF, like all the way like that. But we will check all these details step by step. Let's join you and see what happened. Okay, a little bit slow. All right. What's FFF in decimal? Okay, I told you the first we talk about 8 bits, right? So 8 power of 2. That point, it will be like 60. We will look for hexadecimal. I told you. Now let's look for it. 0 power of 16, 1 power of 16, 2 power of 16, 3 power of 16. It will be 4006 possibility in 1 point. Okay, because we are looking in F, power of 16. Let's come down. Because look, 2 power of 16, it will be 256, right? Anyway, it's like 8 power of 2. Yeah. Each F represents 15 in decimal. So that's 15 times 4096. 15 plus 15 times 256. 15 times. It's like the other one, okay? 15 times 16 and 15 times 1 is grand total 65,535. We can also calculate that based on the binary representation of FFFF. Each hexadecimal digit F corresponds to 1111. Look, it will be 16, right? In binary. We're calling it for that FFFF. Okay? So that results in the 16 bits. It's all will be like that. Okay? Because remember, for 8, what we said, it 111. It will be 8. If we say 16 bits, it will be 1111. 4 digit, not 3. Yeah, let's come down. As we discussed in binary numbers, the highest number that can be represented by binary digits is 2n power of 2 minus 1. That means the binary number above is uh, 16 power of 2 minus 1, which once again equals 65,535, which is the same way. Just we saying this not 8 power of 2 minus 1, just taking is 16 because we are calling like IPv6. We're talking about IPv6, not IPv4. If you say IPv4, it will be 8 power of 2, okay? Let's look here. Each 4-digit hexadecimal number can range between 0 and 65,535. Look, this is very important. Each 4-digit in 16, okay? It can be that. This is very good. So each number can represent 65,500 to 536 unique values, and there are 8 of them. In total, each IP, now if we bring all of them together, 8 times 16, it will be 128. It will be 340 and decillion. It's very very big number. Anyway, let's read here. In total, each IPv6 address is represented by 128 bits. So there are two is like 128 power of 2 possible IPv6 addresses. That's 340 and decillion. In 8 bits, this communication will be like what, In 8 bits, it will be like how many plays have? 4 plays and 8, 16, 32. 32. It will be 32 power of 2. It will give us little than 314 and this number, okay? Which is this number. Look, it's very big number for represent computers or for append their new devices with the new IP addresses. Okay, let's say imagine a world where we have that many internet connected devices. What does that look like? How could that much internet usage make the world better? What's your IP address? Let's talk a little bit about that. One way to find out your computer's IP address is by searching Google for IP address. Google knows your IP address since your computer sends a message to the Google computers as soon as it loads google.com. Your IP address might be different tomorrow than it's today. Each ICP has a range of addresses they can assign, and they might give you a different one of those addresses each time they see your computer pop up on the network. That's called dynamic IP address. So we will check it too, okay? We'll do all of them together. Maybe I can see from here something. IP address. Let's go settings. Okay, until come this page, we look here. Uh, yeah, it's here. Let's go network. Not network. Maybe go maybe that's special. Let's look for IP network. Mm, Let's go Wi-Fi. Maybe. Yeah, let's say sensor. Oh, why I'm interested with this kind of place. Let's go. Uh, what happened? Crazy things happening here. Right here. Let's say IP. Maybe let's call it IP. Uh, mm, uh, Propose. I think I remember good. IP. Yeah, IP. Where is man IP? Let's say man IP. Yeah, how I can go there? Let's see. IP. Let's look for the address. What I need to write there. Uh, Details. Yeah, let's try it. Yeah, yo. Let's say IPE. Oh, I think this is the. Let's say IP address. Address. Yeah, yeah. This is the IP address. Look, that point you will see here, right? One, two, three, and four. This point, our this provider, and this is my computer. Okay, this point is my IP address is here. Okay, and this point will be IPv6, but let's look the right FFFF. This we calling it like that. Anyway, we will speak about it. This is another point you can see. Um, okay, I think you got it. What I'm saying, right? Our IP is there. Let's come down. Let's say switching to a different Wi-Fi network will definitely give you a new IP address since each Wi-Fi provider has its own range of addresses. What it can do out. Maybe let's look again there. We can say man Wi-Fi. There is no information for Wi-Fi, Wi-Fi, or let's say what you know. Propose propose Wi-Fi. Oh, there is nothing. Propose Wi-Fi. Um, let's say mm, internet. No, anything there. Anyway, let's later we will look for it. So, computers that act as servers, like the computers at powergoogle.com, often have static IP addresses that makes it easier for computers to quickly send search requests to the Google servers. If you typed out IP address above, you hopefully found yourself on the Google homepage. Okay, so you need to understand about 8 power of 2, which is 4-digit place, like one. So 4 part there, 2 part for the provider, 2 part for you. And for the eighth power of 2, we will look in other way. Anyway, let's come with me. Okay. Check your understanding. Let's check your understanding. Identify whether each address below is IPv4 and IPv6 or invalid. Let's do it together. I, I will take my pencil and will come and will take yellow. Not yellow, sorry, green. Now the first one. What do you think? This one I think IPv4, 8 power of 2. Each point can be between 0 and 255. Okay, look, same point. It's and this, all places 8 bits can represent 8 bits. And we know this 32 power of 2, it's the possibility IP addresses there. This one is that. Look, I will that I will do green. This is IPv4. And let's come down. This one, look here. What can be? What do you think? Do you think it can be IPv4? What do you think? Just think about it, okay? Look, this is between 255 and 0. It's also there. It's again 8. 8. Anyway, 8888. This is again IPv4. 258. 58. This is not true, okay? Cannot be true because we have only range between 255 and 0. This is more than 255 and it cannot be IPv4. It's different things. It's invalid, okay? This is not true. This one, just check it. We have here 4 digits. We can say 16 bits. This place is 16 bits, right? This place also 16. This place also 16, which is we can say we have 4096 possibility in each FFFF. But this is not true. It is not IPv6 because this is just 4 digit, 4 part. We need to put here 8 part. So 8 part, sorry for here. 1, 2, 3, 4, 5, 6, 7, 8. If it be there 8, then it will be IPv6. Because why? We will bring all of them. It will be 128 power of 2. This is not true. Okay, this is invalid. Again, look here. Down little bit. I will clean down. Where is my face? Right. So yeah, 1. So again, 16, 16, 16, 16. It's all the way going 128 bits there, right? 228 bits. Power of 2, it will be our good solution. So which is, we have 8 part, right? 1, 2, 3, 4, 5, 6, 8, and each place is representing 15 bits in place. It is true. Again, it is IPv6. In this place, 1, 2, 3, 4, 5, 6, it is invalid. Okay, this is not IPv4 or IPv6. I think you got it, right? I think. Now, our new topic will be what? Will be IP, IP addresses, addresses, hierarchy, 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 right here. This is our new topic. Like what? Like that. Okay, let's go a little up. Okay, let's say for this thread, this is because our new topic. I can take this one little down. Oh, what happened? Right, I'm worrying. Just don't do it. Yeah, it can stay here all the way. Okay, this is our new topic. Next lecture, we will talk about IP addresses hierarchy, and we'll talk about IPv4 address hierarchy, IPv6 address hierarchy, subnets, and more, splitting octets, and we will look all of them. Okay, just don't worry. We'll talk all of the details about IP addresses, how they are representing each other. Like, so we will look all of the hierarchy of them. Thank you so much for joining. Have a good time. I appreciate you there. I hope I am helping you to learn about computer science, basic fundamental of computer science. Thank you so much. Have a good day.